Hi guys, this is the Cody. I welcome you to another video tutorial where we are creating an ASP.NET Core application with Angular 10. In the last video tutorial, we created our application DB context. This is the part 2 of the video tutorial where we are creating the database for our application. And if you haven't watched the part 1, I recommend you to go ahead and watch it because you would need to install certain packages from NuGet in order to implement the components of this class, which is the data protection keys context class. So go ahead and watch it and then start watching this part 2 video tutorial. In this video tutorial, we will be working on the data protection keys context. Now, why do we need a data protection keys context? Now we are going to implement encryption in our project. We will use this encryption feature to encrypt the data of our users, like their tokens, their cookies, and so on. Now, while we are encrypting this data, we need to create some cryptographic keys, and these keys will be used then to decrypt that data. These cryptographic keys by default are stored in your computer or basically in your development machine. So ASP.NET Core has a data protection system where it uses a discovery mechanism basically to decide where it needs to store these cryptographic keys. Usually if this is not specified explicitly, these keys will be stored on the development machine of the developer. So therefore, the developer can override this default discovery mechanism that ASP.NET Core uses to store these keys by explicitly specifying a place to store these keys. In our case, we are going to store these cryptographic keys in our database itself in a database called as data protection keys context. Now, if you don't want to store these keys or in your database, in your local database, you could go ahead and store these keys also in Azure, and you can read this documentation provided by Microsoft which says key storage providers in ASP.NET Core. I will leave the link in the video description. Here there are different options where you can store these keys, cryptographic keys. You can store it on a file. You can also store it in Azure. You can store it in Redis if you are using a Redis database. You can store it there. It's an in-memory database. If you want to store it in system registry, you can store it there. Or if you want to store it in your local database, you can store it using EntityFrameworkCore, which we are implementing in this project. So I'll leave the link in the description. Go ahead and read this documentation if you want more information on key storage providers. So to implement this class, first thing, or to implement data protection key storage, we need to first extend or inherit this class from DB context. And let's add the import statement. And also we need to add a reference or extend it from the interface for data protection key context, data protection key context. Let's add the missing reference. The missing reference is from the package that we installed, which is the ASP.NET Core Data Protection Entity Framework Core. As you can see, now we are getting this error because we have to implement the constructor which is needed. So let's go ahead and add that constructor. So we have implemented the missing member, which is the DB set, and also implemented the constructor. Now the constructor will be used by our DB context, similar to what we did in application DB context, where we are passing the options to build that database to the base constructor. We are going to do that inside the data protection keys context, where we will be passing the context options from the data protection keys context class to the base constructor, and then we will implement the member which is required to access, which is the DB set, to access the data protection keys. In order to get all the data protection keys, the application can use this DB set. So that should be it for this class, and I will also leave the link in the video description. Now the next step is to go ahead and work on our database context initializer. Now, why do we need this database context initializer? When we start or run this application for the first time, we need to make sure that our database is created. We need to also make sure that the roles are created. We also need to make sure that we have at least an admin user and a demo user in case if we want to show a demo to someone whom we want to sell this application or whatever be the reason. So we need, when we run this application, when we deploy this application and run this application for the first time, certain database tables or certain information needs to be there before we start this application. So that's why we need to initialize our DB context with certain information. Therefore, we'll be using this class to do that operation. Now, the first thing that we want to do is this class will make it static. So we don't have to create any instance of this class. We can directly access this class. The next thing I want to do is inside this static class, I'm going to create a static method which will be public static async task. This will be an asynchronous task that will be performed by this method. I'll call this method as initialize. Why? Because I'm going to initialize some information where I'm going to pass some parameters and then I'm going to do the initialization. Now let's add the missing reference to system.threading tasks. Now here inside this method I want to write all or perform all the code or write all the code that's going to do my initialization. So here this is what basically we are going to do. We are going to check if the data protection keys context database is created. We are going to check if the application DB is created. We also want to make sure that if the DB contains any users, so if the application was run for the first time, that means already the users are created. We don't need to create or duplicate those users, create them again. And if they are not created, if the database is empty, we will create the admin user and the app user. So now the first point here is to make sure that the data protection keys context is created and the application DB context is created. So to do that, first thing I would need to do is pass in the data protection keys context, call it data protection keys context in the parameter, and we'll also pass the application DB context and call this application DB context. And here now what we want to do to wait for the creation of data protection key context. So in EntityFrameworkCore we can call the database dot ensure created method to check if the database is already created. So that's how Entity Framework is a very powerful framework that we can use and comes with a lot of features. So here we are going to use the asynchronous method. So we will do the same with the application DB context as well and make sure or ensure that these databases are created before anything else. Now the next thing is we want to check if the application contains any users, and how do we do that? So to access the user information from the application DB context, we can go back to the application DB context, and here we have created a DB set to perform the CRUD operations basically. So we can check using this application users DB set if the DB set contains any users. So going back here using the application DB context, we will call the application users DB set and then call the any method. So we are going to use this in a condition. So basically we want to do if application use DB context dot application users contains anything like any users, then we don't do anything. We do not create a new user. So let's add the missing reference to system.link. So we are just going to return nothing. So this will end the further execution. But if it does not contain anything, that means there are no users, we would have to go ahead and create it. So we would have to create this admin user and app user. For creating this admin user and app user, we are going to create another service, because we are not just creating an admin user and an app user. We also need to add additional properties like default user address, the name, last name, and all the additional properties that we set for the app user. We are going to create that as well. So we need to specify some default values. So we are going to do that using a service called as functional service that we are going to create now in this project. So let's go ahead and create this functional service. So let's right click on our project, add a new project. Once again, we will go under web and console, library, class library, and select next. Make sure you have the .NET Core library class selected. Let's call this as functional service, and here we are going to browse and make sure we are not inside the main project. So we want to create the project inside the folder which contains all the projects. So let's click open. Then let's create this new class library project called as functional service. Let's delete this class. We don't need this. We are going to create our own class. Now inside the functional service, let's start working on the requirements for creating the default application admin user and the app user. Now inside the functional service, we would need to add two packages. So let's go ahead and add those packages. We would need the package that is ASP.NET Core identity.EntityFrameworkCore, and we will make sure that when we are adding the package here, we add the same version that we have in the other projects. So let's go ahead and now go to new get packages from functional service, and then search for Microsoft ASP.NET Core identity.EntityFramework. We will install the latest stable version, but the version that we had already installed in the previous project. Just matching the same version, we will add the package. Accept the conditions. The package is installed. Let's also add another package. Search for Microsoft.ASP.NET Core.Identity, and we will install the latest stable version, which is 2.2.0. So add this package. Accept the conditions. So the package was successfully installed. Now we just need these two packages at this point. So now let's go ahead and create two classes in this functional service project. So I'll call this class as functional SVC. That's the functional service. I'll also create an interface to access these class members. So I'll create an interface, and I will call this interface iFunctional service. Let's add the extension for the interface, and now here in this class we would need certain objects or certain properties that we need to instantiate before we start using them, and we'll instantiate them using dependency injection in the constructor of this class. So we will need two more model classes. So let's go to our model service and add a new class. We'll call this admin user options. We'll add another class. We'll call this app user options. Now we don't need constructors in this class because it's our model class. Now we will add the required properties for our admin user and for the app user. So we can add the following properties: email, password, username, country, first name and last name. We'll do the same for the app user as well. So add the same properties. Save this and we can close these classes. So in our functional service class, we need to create certain objects. So we would add the read-only properties for admin user options, app user options, and the user manager, which is a part of Microsoft ASP.NET Core Identity, the package we installed, and the reference to our application user. Now these three classes are inside the model service. So in a functional service, we need to add reference to model service. Click OK. And now we would be able to reference these classes inside this project. So using model service, we should not see any errors. In the constructor of this class, we will be injecting the dependencies and instantiating them. So let's add the following in the constructor using I options. Now we can add the reference to Microsoft extension options, app user options, so let's add the remaining references, remaining properties. So I have instantiated these members inside the constructor. Using dependency injection, we will be injecting this properties in the constructor of functional service. Now we would need to create two methods, one to create the default admin user and one to create the default app user. So inside these two methods, I'm going to first thing create a try catch block. So if there are any errors while creating these users, I can catch those errors and log them. Now to log the errors, we have already created a logging service. So let's go ahead and reference that in this project. Click OK. Now here all we need to do is call the serilogs static log method to log the errors. So that's how we will log these errors, log.error, and we will add the reference to using serilog. Now the same thing here, I'll just copy this. And now I need to add the logic inside the try block where I will add the user's information in and then add that user to the database. So first let's create the user using the admin user options that we have here in the constructor. So here I have created an object called as admin user, which type is application user. And to create the profile pic, I am going to create a get default profile pic method. So this method here, which is the private method, we will be implementing this method in the future. For now, what we will do is just return an empty string. So for now, just return an empty string. We will implement this method in the future. For now, we just want to create a default user because we would need to learn how we would implement and upload pictures in our project, and during that time we can implement this method. So for now, I'll just leave a note here. So let's add the missing reference and here. So now these are the properties for the user. These are the values that we are going to add. So we also need to make sure that after we have created an object of type application user, we add this object to our DB set, which is the application user. So let's go back and let's add this using the user manager object that we created. Now user manager is a part of ASP.NET Core identity. So by using this object here, we can access the application user table and we can insert the data inside the table. So let's do that. So here I'm going to assign the result of this operation, which is user manager.create async method, and I'm going to wait for the result. So the create async method requires us to pass an object of type application user, which we have created, and also to pass the password that needs to be used to create that user so that the user can use that password when they are logging in. All these values like email, username, we will declare them in the app settings. But for now, let's just focus on this method. We created the object. Now we are inserting the object inside the database. Now we need to know if this operation was successful. And how do we do that? So we can just use the result object and then use the succeeded property of that result object. It's a boolean, which means if it's true, we can do certain tasks, and if it's false, we can do certain tasks. So if it is true, if the user creation was successful, I need to make sure that I add this admin user to the administrator role that we have created by default in the application DB context. So when we are initializing the DB context, we are making sure we are creating two default roles, administrator and customer. So after the user is created, I'm going to add that user to the administrator role since the user is an admin. And I'm also going to log information in my logs that admin user was created. So if something goes wrong and the result of user creating was failed, so I also need to make sure that I collect those errors and log them in the error file. So to do that, I can just create an error string array, which will then join all the arrays, and then it will I'll create an error string which will join all the errors arrays into a string, convert them into a string, and then log that errors into the log file. So this should be it for admin creation. Now let's go ahead and do the same for the default user, which is the app user creation. So we have created now an app user using the application user object, and we are using the create async method of our user manager, and we are passing the app user object and the password for the user. If the result is succeeded, we need to add this user to the role of customer. Make sure the user is a customer, not a admin. Now the next thing, if there's any errors, catch the errors and log them. If anything fails, we catch the exception. So that should be it for these two methods that we need to create the user and create the default admin user. Now we need to call these methods inside the service, which is our data service, and go to the DB context initializer, and here we need to call those two methods. So to call those two methods, first thing I need to do is reference this project, which is the functional service project inside the data service. So let's right click, add reference to functional service. Now I will have access to all the methods inside functional service. One more thing that we forgot to do, since we are inheriting from iFunctional service, we need to specify this methods in the interface. So let's add them here, and also add this method, which is the task to create default user. So you don't need to add the method body in the interface, just need to add the reference to those two methods. Now going back here, now we have the reference added to our functional service in data service. All we need to do is we need to pass the iFunctional service interface, create an object of functional service, add the reference using the import statement, and now we need to, using this object that we just created, which is the functional service, call the static method, which is the default admin user. Since it's an async method, I need to add the await operator. Now let's also create the default user. So these two methods now would be called. So what are we doing here? We are checking if the database has any users, then we return, we end the further execution of this initialize method. But if the application database does not contain any users, then we go ahead and we create these users by calling these two methods that we just created. So this should be it for this part of the video tutorial. Now in this video tutorial, what we did, we created the functional service, we completed the data service, and now in the next video tutorial, we will learn how to update our app settings file, add the reference or add the connection string to our database so that the database can be created using the Kitematic application where we created the database container. So we will do that in the next video tutorial. So if you have any questions, use the comments section. All this code will be posted to the GitHub repo and you can download it from there. So thank you for watching. Please like and subscribe our channel Tech Audi.